curious about DQMH? Yeah? What have you heard?
It's looking for an alternative to the actor framework.
Okay.
The framework's very complicated.
This is Stephanie. No, he already left. Okay.
So one of the reasons I thought this would be a good presentation to give is because, in my opinion, DQMH is a lot easier to get started with than some other frameworks. I'm going to be writing a lot of LabVIEW code, but I'm also going to try to point out, or maybe Fabiola will point out, there's a lot of code that's written for you in the DQMH. In fact, all of the communication between the modules that we're going to write, I'm not going to write a single line of that code. The firing of user events, the creation of the type defs that are passed by user events that are communicating between one module and another, I'm actually not writing any of that code. All the code that I'm writing is purely the logic for the modules that we're trying to implement today. So that's one of the, in addition to all the cool shortcuts and things you're going to see me use in the editor, I'm also hoping this presentation illustrates just how easy it is to get started writing an actual application with DQMH.
So are you starting with the template?
Yes.
No, he's starting from a blank project and adding modules.
So while Fabiola is talking to you guys, or while Luis and Fabiola are talking to you guys for the first 10 minutes, I'm going to be creating new DQMH modules from template.
But it's not going to be, see, DQMH has two templates. One is the project template that comes with the application and the singleton and the clonable. And then there's another menu option where you can start in a blank project or your existing project and go to Tools, Delacor, Add Module. And then it adds individual DQMH modules to your application. Okay?
So I'm starting with 3 blank DQMH modules once you see me start coding.
So the main thing is, and I've heard, actually this and I've heard like 4 or 5 times, this is a story that is going to make sense. I promise it makes sense.
You have 1 minute.
Yeah, I have 1 minute. Okay, so there was one of the students that took my Advanced Architectures and LabVIEW class, and I was talking about the importance of using templates. And he said, why would I use a template if I can create a producer-consumer from scratch in 5 minutes? And I told him, okay, I'll time you. And he started coding. And what happened when he was done with the producer-consumer in 5 minutes? He couldn't find it. He was running and he couldn't find the bug. And it was a pretty big bug. He put the dequeuer outside of the while loop. Okay? And this is what I tell people. If when you're programming, you hear yourself saying, oh, I did it again. Oh, I forgot again to do that. Oh, I forgot again to destroy my events. Oh, I forgot again to destroy the reference. I forgot again to name the event. Whatever is it. How many of you have said that to yourself? I did it again. Okay. So the DQMH is starting from template. What we do is we program all those repetitive tasks. So LabVIEW can be the one that says, oh yeah, I did that. I know how to do it. I'll do it again for you. And then the developer can focus on just solving the problem at hand. So are we ready?
Let's get this show on the road.
Okay, so it's 3:30. What, you need it? Oh, yeah, you need it. I guess you don't need it. They want it. Yeah, that's true. You don't need it. They want it.
All right. Ready?
I'm not doing anything for the first time.
Yes, you are. You're adding 3 modules.
All right. So you guys know Fabiola, and you guys know Darren. My name is Luis Orozco. I run the hardware side of things at Delacor. And they don't let me out very often. They decided that they let me out this time. So rapid application development with DQMH. Darren's getting to work here. There we go. So DQMH means Delacor Queued Message Handler. Woo! And this is something that the software guys at Delacor created so that we could use it in our own internal projects, that we could give it to our customers, and when they called NI for support, they would be able to help them because it's a known architecture based on a queued message handler. And it's accessible to CLDs. Some might even argue it's accessible to people like me who are CLDs or CLADs or see anything. At one point I took the CLAD test in the past. That was like years ago. Anyway, it works with Testan. And we get some customers that like to work with Testan, so good for them. And it uses object-oriented programming, but does not require understanding it, which is, again, great for hardware people like me who don't understand object-oriented programming. and supports multiple instances, which I guess that's important. You can ask Fabiola about that. Again, I'm a hardware guy. Has a lot of scripting tools so that people like me can just click a button and create events and things that I don't understand, but it works, right? So again, you'll see here in a minute. And we won last year as LabVIEW Tools Network Product of the Year. This is on the Tools Network. It's available for free. This is sort of our marketing budget. Instead of spending money on brochures and pamphlets, we spend money developing a product so that when people ask, can I see your work? I say, well, no, because we're under NDA with most customers, but you can go see that, and that's the sort of quality you can expect from us. So, prerequisite to enjoy the presentation is to at least know what it is or have a general idea. I think you'll have a good time even if you don't, because this is going to be entertaining, judging by the rehearsals that we did. And there is a website you can go to learn more about it and see things in slow motion. So the challenge for today is we have a unit under test over there. It's a Peloton bike that it just came off the manufacturing line and needs to be tested. And there are two tests we want to do. One test is we need to get the thing moving, get it up to 60 RPM, make sure that the sensors report the correct speed, that the bike is actually moving, that there's not stuff binding and manufacturing defects. And we're going to test the power supply, make sure that it's getting the correct voltage to power the electronics in the bike. There has been a driver for the bike already written. We weren't expecting Darren to write the serial driver and a measurement driver here in an hour. So he's starting with that already done. And other than that, he's starting with a blank application or a blank project. And at the end of the presentation, he will have an executable that we can deploy. And as you will see, this makes development go really fast.
But we still had to go with it.
It helps having the fastest developer in the world, too.
Well, I know, but we have the fastest developer now. He retired from competition. Darren retired from competition, but he still is fast.
Okay, at this point, they're going to start talking about hardware and whatever, software. And the only thing I'm good for at this point is pedaling the bike when it's ready. So.
He's the hardware guy, so he has to deal with the hardware.
I'll play on my phone.
What was that?
I'll play on my phone and browse the web.
Okay. I'm sure Darren will let you know when you need to start. Okay, so we are going to do some modeling here so you understand what we are trying to do. And I recommend doing this if you are working with anything that's actor-oriented, whether it's actor framework, DQMH, anything that relies on having processes running in parallel. It's good to draw it first. So we're going to have a Peloton bike RPM test DQMH module. We're calling that the application DQMH. We're going to have a power supply module. And we're going to have a DQMH module for the RPM. Then, just a refresher or a new concept to everyone here. A request is code that fires an event asking the DQMH module to do something. Multiple locations in the code can send events to the DQMH module with their particular requests. It's many to one. This is a type of asynchronous event. The code that fires the event does not wait for the response. It doesn't even wait to see if the message got received. It just says, please, whenever you want, do something. Right? I'll be here. I won't wait. And if you do need to have the reply, then you do a request and wait for reply. In that case, the calling code does stay there until the reply is received or a timeout happens. All right, broadcast events. So broadcast events is code that fires an event telling the world, telling the rest of the code that the main module did something. Multiple event structures can register to handle the event. It's one to many. And that's really all you have to know. So request, broadcast, is there any question on that? Is that pretty clear? I asked for something. And I subscribe to learn about it. The Peloton bike application module, so that one's going to have the default DQMH modules. All DQMH modules already come with start module, stop module, status updated, module did init, module did stop, and so on. Like a show diagram, show block diagram. The Peloton power supply DQMH is going to have those default events plus a request and wait for reply. And it is a request and wait for reply because we are asking it for the voltage, waiting to get the voltage. If the voltage is not what we want, there's no need of continuing the rest of the test because that means the bike is not on. So that's why we decided to make that a request and wait for reply. Any questions so far? No? Okay, third module is going to be the RPM module. Same thing is going to have the default events plus we're going to create 2 requests, a start RPM test and abort test, and 2 broadcasts, RPM status and the final result. So if I were to put these with arrows, this is a request and wait for reply. I said get voltage and I got the reply back. The start RPM test is just a request, so everybody else can go do whatever they want. There's no waiting back. The RPM status is a broadcast, so you saw that went all over the place because right now we're only going to see it go to the main application, but other modules could be registered for it. The abort test is a request. The RPM test result is a broadcast. All right. So why do we do separate modules? Anybody wants to jump on that one? Encapsulation, yeah, that's a good one. So what if we had a monolithic application that contained everything, the power and the RPM code? Months later, somebody comes back and says, now we're going to do the brake test. And the brake test uses the power supply test as well. If I had done a monolithic application, means that I'm going to go and have to rewrite all that code. Where if I already have modularized, I can just take the status module, power supply module, and move it to the new application. Okay, so that's why we program on. It also makes it easier to test, which you're going to see. And we have been recording Darren, so this is what he has been doing. And because it goes really fast, the video is going to go super fast. So we have a blank project. It's named RPM project. It's going to DQMH, a new DQMH module. And this is how he added the 3 modules. The Peloton RPM, which is a singleton. And now he's going to add the power supply. Oh no, we're going to change the virtual folder to make sure that we have all our API testers in one side and all our modules. So both the library and the tester were created automatically by the tool. And all of the code that you're seeing there was created by the template. So now we're going to add the second module. That's going to be the power supply module with its tester and its module. And finally, we're going to have the application. All right, so you ready? Okay. So, on your marks, get set, and...
All right, so we've got all of we're starting with the templates that you just saw in the video. So the first thing I'm going to do is write the power supply module.
All right, so he is, and I need to see what he's doing so I can be the sports commentator here. So he's going directly to the main module, and he's using Quick Drop there. Anything that you have on your project is available to you via Quick Drop. So he just typed the select device. And he is setting from there the device. And you can see that we are actually using classes there. The device is a class, but the module is not necessarily using classes. So now, he's going to be passing the information by value to the main module. To do that, we are using VI server control value set. And for that, you need to know what the name of the control is. So he copied it from the control itself. He's passing it as a value. And that's how we are ensuring that the main module is going to get that value. Now, he is going to create a request. And it's a request and wait for reply to get the voltage.
You can watch on my screen.
Yeah, I'm going to be watching over his control with me. And did you put an argument on that one? Nope. No argument. So he didn't need an argument. And now this already was coded for him. The tester was coded for him. And all he's doing now is realizing what is the better reply. So the reply is going to be the voltage. So he has to replace the dummy there. And he's going to put an indicator. Now, he's putting a button there that he's going to press when he gets the voltage. Now, he's going to be using a right-click menu that he downloaded from the right-click. Oh, by the way, we'll show you all those tips that he's using to program like a madman. So you can program like a madman at home. Don't recommend it. You can do it at a friend's house.
We do recommend it.
Okay, Darren does recommend it. He's being nice to you guys. He made the letters bigger. And now we're going to the main module. On the main module itself, he knows that he has the device, because remember he selected the device in the initialized case, and he is going to feed the voltage. And he's also feeding the error, so we can stop waiting for the event if there was an error, and whoever was waiting for the reply can get it. So he's running the tester, starting the module, and you get an error. What happened?
I don't know.
So there's an error. So he's going to debug. So he's using the tester to figure out what's going on.
Go on and test it.
Yeah,
Yeah.
we need to check that the API works. So we thought it was working, but
Yeah, it's working.
so all right. So it's not the API call. So maybe DQMH broke something, right? That's the typical thing. It was not something I did. Oh, voltage channel? Is that the problem?
That's right, right?
Yeah, that's right. AI 0.
Okay.
Start module, Peloton bike. Empty stream. The main task. Is this the surprise you had for me?
Nope.
I think if you go to measurement in our Measurement Explorer, it might be that we need a different name. He had said that he was going to put a surprise in for me, so
This is not the
I
surprise.
thought this was going to be the surprise. Yeah, surprise, it doesn't work. No, we tried it! But if not, I guess you could run this part in Simulator.
Where are you setting the actual device name for the DQMH name?
Yeah.
DQMH device is coming out of the power supply.
It's not getting the problem is that it's not recognizing the DQMH device.
Where are you populating it?
The device is not named, just
You've
the
never
channel.
put it in there.
No, because the driver has it. The driver detects the first DQMH module that it finds. Is it connected?
Yeah, because the tester worked.
Yeah, that's where the tester works. And this is why we don't like hardware.
Just put Dev 1 AI 0 right there.
It doesn't say Dev 0 on it.
Hardware is working.
You didn't initialize it? You think that that's the
I think
problem?
that's the problem.
All right. Yeah, because you need in some place to have the magic that detects the first. Yeah, there you go. Woo! We didn't use the tester to actually show the block diagram. We should have done that. But anyway.
Oh, yeah.
Hardware does work if you initialize it.
Yes. Thanks for working.
Don't you have a bike to pedal?
All right, so that's the power supply module. Any questions so far? We now have a reusable piece of code that we can use to read the power supply and make sure we're getting the right voltage to the bike.
Okay, so we have already some
Yes.
people with.
The get set control value by method, which part was that in again?
That was when we start the module. That's our way of passing values to the module when it starts running.
And there's a reason we're not using start asynchronous. The reason we're not using start asynchronous
There's a very good reason.
is we need the VI to know the status of the VI, because remember that you can register to send requests different places in the code. So for that, this is a singleton, that means it's a single instance. So every time that I start the module, I need to make sure that I'm receiving the same reference to the VI. So what we do inside of the start module for you is to check if the VI is already running, it's bad, or it's idle. A start asynchronous call, for whatever reason, you know how it is call and forget? It seems that it also forgets its status, and you cannot get whether it's running idle or bad. So that's why we use VI server method. And believe me, we had R&D look into it. Oh, cannot be good.
All right, so I'm going to write the RPM module now.
So questions about power supply module?
Do modules have to be singletons, or is there a way?
No, there's an option for clonable. We're not going to be seeing clonables today because that's a little bit more complex.
Okay.
But there's, when you do DQMH add module, you can just say, I want a clonable.
Okay.
And you can also create your own templates, but I'm getting ahead of myself. Okay, initialize case on the RPM device. So this time we're selecting the device. Please do not forget to initialize.
I will not.
All right, see, he copied the serial class, and then he's putting the button there for the test running. And we are going to feed our device into the local data. So he's putting the device there, and he has a flag. Is the test running, right? So we're initialize, the test is not running. We're going to do the same trick of putting the device type inside the start module. So here on the start module, here's where we set, you can see at the left there, there's a VI that checks the status of the module. So if the VI is actually idle, then we would go in here. If not, we will just return the reference. And here we go. Now that the initialize is done, he's going to Delacor DQMH, create new event for the RPM module. This is a request. Now we're going to start with the RPM, start RPM test. And LabVIEW is busy back there. You have your monkey writing code for you. And we're going to
Is that what
add.
you call me when I'm not around?
I'm not calling you monkey. I'm calling monkey the scripting tool. Right?
Sorry, I got this.
Wait. Okay, you're testing. That's good. So he went directly to test, but you didn't implement the code for that. That's risky. He is taking risks here. He went and created 2 requests back to back without actually implementing the code.
But I implemented the test of the code.
Well, he implemented the test of code, which means that if he tries to run it right now, it's going to fail because the code has not been implemented. So on his tester, he has created the abort RPM test and the start RPM test. And the main BI, right now, you see the scripting tool, or the monkey, already created the event on the top, and it also created the abort RPM text, and it's also created the case for you in the case structure at the bottom. So all he has to do is the unbundle by name and getting all fancy there when he places the placement structures. And... All right.
I remember to initialize everybody.
Yeah, oh, he did initialize. Does he get an applause? No? They don't applaud when it's supposed to be your job. All right, so he is enqueuing, and I have a whole debate about whether you should be enqueuing from here to another case, but it's okay. He's just starting the RPM, and now he's going to the read RPM case. In the read RPM case, he's getting fancy again. In placement structure to get the device, and he is getting another VI from the driver that actually reads the RPM. So I guess you have to report to someone what you read, right?
Uh-huh.
Why do you have a timer there?
So we don't go so fast.
Oh, you don't want to go so fast. So sometimes you do slow down.
He hasn't slowed down, the code has. That's different.
Yeah, that's true. The code is the one. The code does need to take a break, unlike me and Darren. All right, so the RPM, and now he's creating a broadcast. He pasted on the argument window the RPM, the time at target, named it RPM status, and the monkey goes back to coding, and he created a new event case. The event case is already registered and wired for the broadcast event. If you were using LabVIEW earlier than 2016, you wouldn't have that last step done for you. You would have to do it, but it started on 2016. The monkey does, the LabVIEW scripting does finish wiring everything for you. All right, so he is making sure that he has everything he needs. There's the start device. Again, this is the RPM module. We had done the start of the power module before. And the VI, the broadcast VI, was placed there floating for him with a note that said, this is the broadcast, put it whatever is it that you want to broadcast, the RPM and the status. So that VI was created automatically, programmatically by the, why did you put a constant that doesn't have a label? I guess he only has an hour. So this is how technical debt is created.
Harsh.
Yeah.
But there's one thing I forgot to do. I forgot to check my flag.
Oh yeah, what we need to make sure that, are you running or not running? See, I'm distracting him. All right, so there it goes, the case structure. If I am running, Oh, right-click menu and tell it to replace by selector. I don't think you want that to be the false case, right?
Test running, false. Don't do anything.
Okay.
I think I want that to be false.
Okay, that's okay. Whatever you want.
Sorry for the messy code, everybody. I'm kind of in a rush. And somebody's looking over my shoulder.
We're all looking over your shoulder.
Yeah. I never do this to poor people that work for me. Then you enqueue test result, but only if you get to more than 6 seconds, because Fabiola decided that was 6 seconds. People, if you have constants like that, they should be in a configuration file. All right, we don't have time for configuration files. He is putting a numerator there, RPM test result. Oh, and look at this. He's going to be doing, what is it that you do there?
Shift enter.
Shift enter, and he's going like crazy, adding all the different enum states. I bet you didn't know that trick. So, oh, and look at that, he's so nice, thank you very much. He named the enumerator -- enum. That's just a trick that I use because when you are using quick drop, if you type -- enum, you're gonna get a list of all the enums that you have on your project. All right, so he's going to enqueue test result pass. Okay, if you're not there yet, go back to the case you were there. If you are done, you go to the test results. Oh, he just copied the enumerator to have it on the clipboard. And then he is calling the driver to close the RPM, the serial driver. And we know that we're going to get the enum.
Hold on, let's do our error handling first.
Oh, thank you very much. He's doing error handling. Very good. This was not done during the rehearsals, and he got such a slack about it that he decided that he was going to do it this time. All right. Okay, so he puts the pass there, and he's going to create a new DQMH, and the new DQMH is going to be a broadcast, and the broadcast is going to be the test result, and as a test result, he's going to put as an argument the test result enumerator. Again, the LabVIEW scripting engine is back there creating code for us. It already created the event case in the tester for us, and it is registered to the broadcast RPM test result. So he's formatting the enumerator into a string, copying the code that is there already on the tester and another case that's going to be updating the status. And the hardware guy is browsing the web.
You done yet?
No.
You'll be on that bike soon enough.
All right. And the scripting tool plays the broadcast VI floating with a note that said, please put this wherever you want it. And you're always passing, man. There's supposed to be an error somewhere. Right?
What?
No?
What?
You put that you always pass. You didn't have that fail case.
Well, if it's 6 seconds, we pass.
Okay. And if not, you have an error. All right. So if you're in the error case, you do report as a test result, I have an error. And in the case that there is an abort, and again, this is a risky thing about not implementing the entire code about the request when you're creating it, right? He said, I'll do it later, and this is what he's coming back to do. You could have forgotten, right?
I guess I could have.
I know you're in a rush, but that is, that's dangerous.
All right.
You like living in the age. Okay.
Ready to fail now? We're done?
Are you going to do the simulator version first, or?
Sure, let's do the simulator version. So the driver came with a simulator, so why don't I simulate a ramp up to 30? All right, that's cool. It ramped up to 30. I'll click abort.
Because we're not getting to the 6 seconds.
Now there's a problem. It's supposed to say abort there instead of error.
So are you going to show the block diagram and troubleshoot?
Oh, I already stopped it, sorry. But I think I know what the problem is. Whenever I copy the code.
You forgot to change it. Yeah, there you go. It's not error abort.
But the tester sure did make it easy to find that.
Yeah, the tester should have helped you with that. So why is it that you didn't run the tester and show people how the tester works?
I'm running it right now. All right, hey bike boy, let's see you on that bike.
How fast?
I don't know. He's going to abort it midway anyway.
Ready?
Okay, pedal. That's a little bit too fast. Hey, you're cheating. You're cheating. You're supposed to get it down.
So wait. All right, and if I start again and abort, then we can abort. Okay, so this module looks good.
Hey, no. Show the show block diagram for troubleshooting.
Okay, so what Fabiola wanted me to do earlier when I had that wrong, when it came back as error instead of abort, there's a button in the tester that brings up the block diagram, and then you can start setting probes and figuring out what's going on in the module while it's running.
Which is okay and awesome on the singleton, but when you have a clonable, it's incredible.
Yeah.
Because it's so hard to find the block diagram of the actual instance you're working on, but the tester will give it to you.
All right, so the RPM module is done now. We have a way to, in a modular fashion, test just the RPM of the bike. Our instrument driver gave us this way to simulate. In case we don't have the hardware, we want to simulate a situation like with the ramp that only goes to 30 so that I could abort and make sure everything looks okay. Any questions on the RPM module? All right, so now that the power supply module is done and the RPM module is done, I can write the actual test application that we want to write. And what you're going to see me do is I am going to, in the test application, my only interface to the RPM module and the power supply module that I just wrote is the public API of those two modules. So read voltage and wait, that was a VI that I created, y'all saw me create. That's a public API interface to the power supply. Start the RPM test, abort the RPM test. Those are ways that the outside world can interact with those two modules. And those are the ones I'm going to call whenever I write the main application. All right, so here we go.
So any questions? So who has used DQMH? All right, do you keep your testers? Has anybody that uses DQMH deleted the testers? Now you already know I'm going to eat you alive if you have, so that's why you're not saying it. All right, so oh, you're already programming. So he's getting on the Peloton bike test. This is the front application. And since we saw that here the hardware guy was going a little bit too fast since he wanted to cheat, we had to actually put a scale of 200 and not the 150 that we had done during the rehearsal. Right? Okay.
That's how
That's hardware. All right, so he just copied one of the buttons that we already had, and he's going to start test and abort test. By the way, Luis called the customer and told him that we were going to bring the Peloton bike and we were going to do an application from 0 to executable in 1 hour. And I'm like, you shut up, we're charging you a lot more than 1 hour. And now there's going to be even a video proof of it. His test is a little bit more complicated than this. All right, but we still do have individual modules, DQMH modules, to be able to test the tests individually. Okay, so he's picking all his indicators. Again, this module is a typical DQMH module, so all the code there was created via the scripting tool. One thing that we get asked by people that are starting to use DQMH is how do I start my modules or my dependencies when I need another DQMH module to pull them. So in this case, the top level application is going to be starting the power module and is going to be starting the RPM module. So he's just using quick drop, and since those PIs from the public API are in quick drop, he was able to find the start module and the synchronized module events. He's making sure that if there's any error when we try to start the modules, that we do not register for the events in that case. Now, why do we synchronize? We want to make sure that those modules have initialized before we start sending requests. We don't want to miss any requests because they're not ready for us. That's why we use the synchronization. That's why there's 2 VIs. All right. Now that we have started our 2 modules and we have registered for them, automatically now we can go to the event structure, and there are all the here. See how I use the royal we there? So the RPM broadcast events, RPM status, we already knew that it was going to give us the RPM and the time at 60. And he added a new event, and this one is the RPM test result. And in that case, he is choosing to do something on the consumer, but he could have handled it here. It really depends on what you like in your own teams. Some people like to leave their event structure completely available to take other requests and not handle things there. And when we press the start test button, we want to go to the case start test. Have you created that case yet?
Yes.
Okay. And then we are going to create a new event case. And same thing, abort test. And I think you were using another one of your magic right-click menus, because I don't have that right-click menu.
That's pretty awesome.
All right, so Okay, so he decided instead of copying the case to just replace it. That's personal preference. And he's using quick drop, and he used the control space, control I to insert it on the error wire. And you remember that the voltage is a request and wait for reply. So that's how we're going to be putting the voltage there. And instead of the module of the RPM decided, and if it's of the power supply, deciding if it's a pass or a fail, in this case we're deciding that the top level application is the one that's going to decide that.
Luis says anything between 5.8 and 6.2 is a pass on the 6-volt power supply.
So we're going to believe him. I don't know. Sometimes the hardware guy, not right, but.
I tested one.
You tested one. What do we tell our customers when they say I tested one? And that's how I put the specifications. What do we tell them?
That one's gonna work. And only that one.
And only that one. That's another topic, but he does consulting for hardware, and that's not how you do it.
That is indeed not.
All right, so in the case we have power supply fail, we're going to be annoying, and we're actually going to pop up.
That's not what I wanted.
What did you put there?
He's our database.
No.
No databases.
No,
No, I don't think he knows databases. All right, and then we go to the exit. That's not LabVIEW. Why would he? All right, so.
I have worked on the database connectivity.
Oh yeah, that's true. That's true. Sorry.
Thank you very much.
Sorry for doubting your capabilities. Start RPM test. All right, so again, he's using quick drop and calling the start RPM test. He called it the API. What does API mean? Is the public interface. And what is the public interface to a DQMH module? All the request and broadcast. In the case somebody presses the abort button, they're going to enqueue the abort test. They're going to go to the abort test case, and in the abort test case, they're going to send the request to abort. Right?
Yep.
Okay. This time I was able to keep up with him. I talk pretty fast, but yeah, I lose him. He loses me. Who loses who? Why don't you do --enum? That's why I give you crap about creating the --enum.
I type enum sometimes.
Okay, but you didn't this time. All right, another formatting to string. The formatting to string, we are going to say what the test result is. I don't know if you guys are familiar with this little trick about formatting an enumerator into string, and it gives you the actual text for the enumerator. Questions at the end, otherwise it's going to get away from me. Okay, exit, and then the true case. And remember, we made the star module. Another thing that we did in this computer is there's an INI token that forces you to all your inputs to be required. But also, the DQMH module does that. When it creates a request or it creates a broadcast, if you connect anything to the connector pane, it will make it automatically a required input. That's because we like the LabVIEW to be the enforcer and not us. So instead of me going and yelling to the people that are writing code, I let LabVIEW do the yelling. It's required, you forgot it. Okay.
How did that hide?
What happened?
I don't know. I hit it, but now it's there again.
Okay.
All right.
You went too fast.
I went too fast. All right, so here's our main app. I'm going to test it with the power supply failing. We should see that dialog pop up that says power supply failing.
All right. Now he's running the DQMH as standalone.
Because this is what we're going to build into the exe. All right, so I got the power supply fail message. That's good. Now I'm going to go ahead and simulate it with good power supply, and we should see that the test starts.
Power supply fail.
All right.
Does the hardware work?
There's another bug in my code, it looks like.
Is this a surprise you have for me?
So
No?
we'll
Okay.
figure it out.
All right, we'll
We have
figure it out.
testers, right?
Yeah, we have testers.
All right.
That you have not been using in the entire presentation.
So, no, I did. We tested the.
Yeah, let's talk in more debugging.
Yeah.
All right. Thanks, Luke. All right, so yeah, we shouldn't be getting this failure right now. These things are wired up, so it's actually using the value that we wired. I'm going to go ahead and go run the tester and see if there's a problem. Okay, so
you have zombies there.
So those two libraries are locked. I shouldn't see that right now. A lot of times when you work with something like Actor Framework, DQMH, other frameworks that have things that run in parallel, you'll run into a situation where you've got zombie code. So something's been started, but it was never stopped, and now what do you do about that thing? Thankfully, since I wrote my testers for my DQMH modules, I can actually solve this issue. So The reason these things are zombies, by the way, is because I wrote the code to start the modules perfectly well, but I forgot to write code to actually stop the modules that I started. So I need to fix that, but first I need to get those zombie modules taken care of. So the way I can do that with DQMH is really simple. If I go open up the tester for a zombie module and click Start Module, since it's already started, I've now sort of plugged into that running code. I can actually do stuff like show its block diagram and things, because that's, even though it was a zombie, I can gain access to it. In this case, all I want to do is stop it, because I screwed up and I never stopped it before. So I'm going to stop that guy, and then I'm going to go stop the power supply, and we should see that those libraries are no longer locked, so I no longer have zombie modules running. So now let me go actually fix what I should have done in the first place, which is stop the modules. There's two places typically, if you start a module in a DQMH, the two places you want to stop it are if an error occurs. So this is my main VI, and this is the error case where something bad happened on initialization. So I'll stop the modules here. And then I also need to stop them when the code exits normally.
That true is that we're waiting for the modules to stop. That's a good idea. If once you build it into an executable, if you don't wait for the modules to stop, you might not be exiting cleanly.
All right, so now if I go run with those simulated devices, hopefully we won't have a failure. All right, sweet. So now we're getting the simulated ramp up to 60, the simulated time coming up. The simulated voltage looks good. It was between 5.8 and 6.2, and then we get that the test passed. So I'm ready to build an EXE. I don't know about you guys. I'm ready to build an EXE, try this out with the hardware.
Okay, then why didn't you run the tester for the top level VI?
So we can certainly do that. So the tester for the top level VI, we could do start, we could show its panel, we could start using it. That works fine.
Why would I want a tester for top level DQMH?
One of the typical reasons people want testers for top level apps is if they want to have like a splash screen, they can turn the tester into the splash screen for the app, and that's what they build the EXE out of.
So why would you do that? If you're having to debug during the application, you saw how you have the status being updated. So now you have your tester as your way of directly debugging. No need for desktop execution trace toolkit or something like that. Okay?
All right, so while the EXE builds, any questions on that last one? So that last module was a little bit different. Our previous two modules, the power supply and the RPM, those are totally intended to be reusable modules of code. We could take that power supply, go use it with our break test or whatever else we want to do, and it's going to work great. It's got the public API we can use. That third module that I just built, the light test, that's actually the top level app. I could have built that as a state machine, or I could have built that as an NIQMH, or whatever I wanted. In this case, I built it as a DQMH, but it doesn't have any public API because it's the top level thing.
So, well, and it has the only public API it has is start and stop. Right?
All right.
Hardware guy.
By the way, if this works, we're done. All right, here we go. We're starting the test.
Oh, and we have time to spare for questions. There you go, there you go, there you go. Pedal. Okay. Woo.
And that is how you write a test application from scratch using the DQMH.
Right, we did it. Okay, there's more slides. There's some. If you want to see all the summary of all his tricks. I don't know why I have my superhero here. I think I was gonna do something with it. Anyway.
But instead, you just looked over my shoulder.
Yeah.
All right.
Yeah. All right.
How many times did y'all see me use the palettes when I was actually writing code? 0. I'll tell you how many. 0, because I used quick draw. I used object shortcuts. There's a ton of object shortcuts I used that are built into LabVIEW. I probably pressed SC for string constant about 30 times during that demo. Imagine how much longer that would have taken if I had to go to the string palette every time I wanted a string constant. For doing DQMH development, I'm constantly dropping the Delacor Queued Message VI, so I made an object shortcut for that. The whole time I was coding, I pressed DEQ to get that guy from quick draw. And then, of course, there's the control key shortcuts. I think everybody's familiar with control space control R, which takes a chunk of code and removes it, but keeps the wires. Everybody loves that one.
Yep.
Another one I used towards the beginning was Control-Shift-V. So I picked an invoke node, actually typed the name of the method, because I happen to know what the name of the method is, and pressed Control-Shift-V and it renamed the invoke node. Way faster than going through the click and there's the list this long and you have to go find the method name that you want. So right-click plugins. If you've never seen my presentation on right-click plugins, I gave it last year at NI Week, at various other events. you can write G-code to plug into the right-click menus of LabVIEW. There are several right-click plugins that ship with LabVIEW already. I may have used one or two in the presentation, I don't remember. But more importantly, I used several plugins that are not shipping with LabVIEW that you get at ni.com/LViewMenus. I don't know if you noticed, but create constant, create control, create indicator, I have those at the top of my right-click menu. For some oddball reason, LabVIEW R&D decided many, many years ago to stick those menu items in a pull right. They used to be in the top level menu. We stuck them in the pull right, which I don't like. So I wrote a plugin, and all it does is it takes those from that pull right and moves them to the top of your regular menu. I probably used that about 50 times in this presentation. Another couple that I used having to do with the event structure, you may have noticed I right-clicked on a control terminal and did create, and then I had a menu called event case, and I picked that and I could pick a value change event. That's not built into LabVIEW, that's a right-click plugin. Makes it way faster to edit with the event structure. And then for DQMH development in particular, DQMH scripting is awesome. You guys saw that I made those new events from the DQMH wizard, and it'll create a frame for your tester for the new event, but it won't map it to a button on your front panel, because maybe you don't want it to be a button, maybe you want it to be a numeric or something like that. So all I have to do is I have the control in my front panel, move it into that empty event case, the case that isn't mapped yet, and just say map this current event case to the value change for the control I just right-clicked on. So that speeds up DQMH development quite a bit. And then there were some other random things that I did. In case you don't know, paste replace is a really handy shortcut on the front panel. If you have a controller indicator on your clipboard that you've copied or cut or whatever, and you pick another control, just select it, Control V will replace the control with whatever's on your clipboard. And it keeps the connection on the con pane if you've got it connected on the connector pane. So that's a really handy paste replace. It doesn't work on the block diagram. I wish it did. Like if I had a decrement on my clipboard and I picked an increment, that doesn't work. But on the front panel it does. Fabiola mentioned this, if you're editing an enum, don't right click and go to properties. It takes forever. Just type in everything that you want in the enum and press shift enter in between each thing you want to add to the enum. Let you skip the properties, let you skip the right click, add item after, right click, add item. You don't need to do that, just shift enter and you'll add them all really quick. And similarly, whenever I'm adding a new case to a case structure, I'll be clicking in the thing and I'll press shift enter. That's the exact same thing as add case after, and then I can type the name of my case. If you do control shift enter while you're typing in the case structure, that's the same thing as doing duplicate case. So it's just a way to, if you're already there, it's a way to avoid having to right click on something.
So why is it important to have all these shortcuts and things to speed development? Well, I mean, there's the love for speed, there's that. It's also not staying on the workflow, staying on the zone. You're trying to solve a problem. You already have a crystal clear idea of where you want to get. And if you start getting distracted with right-click menus and looking for stuff, you are also getting detours for what the task is at hand. One thing that I want to mention that I didn't mention earlier, when we created DQMH, the whole idea was like Luis said, it was a marketing thing. It was to show that we could take your architecture and automate your architecture. We never intended for a lot of people to use DQMH as their new architecture. I guess what happened is they looked at their architecture and they decided that the DQMH was better and they moved to DQMH. So if any of you have an architecture that you love, but you would like it to have some of these repetitive tasks, I did it again, automated for you, let's talk. And we can look at what are the areas on your particular architecture, even if it's actual framework, right? You might be able to automate more than what is already in there. And it's not that we don't like actual framework, we just believe that there's different levels of proficiency, there's different teams. And the idea is to find the right architecture for your team and for your application. Although the DQMH is a very pretty hammer. All right, important takeaways. It is entertaining to see an application written fast, but the practical reason is we really test fast, the hardware fast. How many times you are interacting with hardware, and you do have these mini testers like the tester that came with the driver, but you're not able to exercise the 3 or 4 things that you need to do. So you might have a simulation, but you don't get quickly to test. We believe in the philosophy is the faster to get you to failure fast, right? And give you the tools to be able to figure out why is it that you're failing. So that's why the testers are there. So we test new features early on, almost as soon as we created them. You saw that I was telling him that he was doing risky business because he was not finishing doing the entire cycle when he was creating the request. None of this was proof of concept. It was part of our production code. That's another important thing. Because you are working already with the tester, you could build the tester and send it to your R&D department, and they could be using it as a benchtop, right? And giving you feedback of the things that you are missing. You could use the tester as a sniffer. So there's really no need to do a quick tester when you can just say, right-click, Delacor, add DQMH module, all right? Why would you do that? There's a lot of BIs in DQMH module. Why would I create a DQMH if I only need a simple window? Because when you are adding a module to your code, there's 3 things that you want that module to do, always. Start when I tell it to start, stop when I tell it to stop, right? And report errors. The DQMH module does that from the get-go. If it stops doing that, it's something you did. Right? But that's why you don't go oh, I know how to do a producer-consumer from scratch. Yes, you do. But why spend time debugging the bugs that you have already debugged 100 times? Okay, stop deleting your DQMH API testers. It was really nice to see. I had a customer calling me for support, and we were having a really hard time debugging what was happening, and I'm like, okay, run your testers. Oh, about that. They were all deleted. Some people at least leave them there and they just forgot to add some of the stuff. No, he deleted them. He just wanted the scripting to be faster. And keep your DQMH API testers up to date. That means that the scripting is already doing everything to add the event case. Come on, guys, you only have to add one more button and it's done. And even if you don't think you need it now, you'll be grateful when you actually need it. So that's it. Make sure you fill out the survey on the app. And if you want to find out more about DQMH, you can go to delacor.com, products DQMH. Like Luis mentioned earlier, the bit.ly link there is to our YouTube channel. There's tons of videos there. The one that I recommend you start with is the presentation I gave last year at NI Week, called Decisions Behind the Design, because it does a good, I think, a good explanation about what is it that we took from NIQMH, the traditional queue message handler, and what is it, the automated, and why. And we have a blog, and feel free to, there's also a forum, I forgot the forum, but if you go to ni.com and do a search for DQMH, we have a forum at ni.com. All right, questions?
Feel free to come up and ask me if there was any particular weird thing you saw me do during the demo and you want to know how I did it. Derek, what's up?
On your DQMH module, there's that decent list of virtual folders and VIs and all that kind of stuff. What of those are expected for me to use? What of those are expected for me to modify? What of those are there for
And the help?
Yeah, the help mentions it. I can suggest it to you. Basically, you're not going to mess with much there except for maybe the private folder when you add sub-VIs that your module needs.
But as far as the scripting working, in our help, if you go to the Delacor help menu, in the validate module, it will tell you this is the list of stuff that you should leave.
There is a tool, the validate DQMH module tool. You point at your library and it says, hey, you messed with this folder name and you're not supposed to because that'll screw up.
And you can fix some of those things automatically with the validation tool.
Yep.
To share one of these applications that's not an executable, do they have to have the DQMH installed?
Not the entire package, just the palette. The DQMH has 5 packages. It has the DQMH event scripter, it has the DQMH, the project template, and there's 2 or more, but there's
So they have to install something else as well as get the
it's just the smallest one of all, which is the palette that has the NQ and DQ. And now you would have with any application. Now,
hopefully you're distributing your code with the IPM, so you've scanned your code and found what dependencies it has.
now there's another way they could be doing it. We have the DQMH modules by template, right? So if they just replace that with their own local copy of the queue, I think that would work. I haven't tested it, but I'm going off script here. But that's the other thing. If you don't agree, like for example, you say, okay, I have a producer-consumer, but I like to have my producer on the left and the consumer on the right, and I like them to be aligned, and I like the local cluster to be a class. and I would like to add a little loop inside that takes care of checking the state, just like TLV does. As long as you keep the tags of the event structure, the tags of the register for events, all the scripting tools are going to work. So you don't have to use our template. And there's, on the help also, there are steps on how to create your own templates. And you still would be able to use, as long as it's a producer consumer, you will still be able to use the scripting tools.
Questions?
Looks like you use strings to kind of drive your queued message handler and your broadcast and request events. How do you handle name changes over time? Do you have like a scripting function that?
Name change of what specifically?
I guess either like a queued message handler like action case or one of your event names.
So the event names, there's a tool. You can go to Tools DQMH Rename Event, and it will rename everything except for the case, the case and the case structure, because we don't know if you're calling it somewhere else. But we put a big orange tag that says, A, the event that used to drive this case is gone. Go review your code and see if it's safe to rename it or delete it.
Well, on the same lines, Darren, I noticed that in the main application, one of your strings didn't match the case structure string in case. The case was. Do you have those set automatically? The case to be case insensitive?
Yes, because that's the way every string case structure should be in all of LabVIEW.
Will you show that?
Yeah.
Will you show that in your code? How do you
Yeah.
turn that on?
Yeah, so
Wait, are you saying you don't believe me?
No, I believe that.
So
People
yes.
don't know that.
And he's trying to be nice to the people that don't know that trick, and he didn't mention that trick. And the DQMH module does that for you.
So right there.
Yeah, another thing
It's got
too.
the little glyph in the bottom
Yeah.
corner in like 2016 or so. It tells you when a case structure is set to case insensitive match.
So that's for case insensitive match.
I guess we didn't do a good job with the design of it because somebody told me, hey, there's some weird graphical artifact on my case structure. I'm like, that's not a weird graphical artifact. That's the glyph that tells you that it's case insensitive match.
Another thing is you can see that our DQ doesn't have a timeout input. That's because we believe it shouldn't. Right? This is not a polling architecture. It's go to sleep, wait until we need you architecture. If you insist on having a timeout, that's why the queue is a class. And that's why we put the things that you would want to change, we made it a class. Everything else is classic LabVIEW. So you can inherit from that queue, and I know somebody in the room that actually did it because they wanted the timeout. I still don't know. It was not the timeout? Okay, so something else. Oh no, it was the debugging the queue.
It was status of the actual module.
The status of the action. Okay. So you can change it, and you inherit from the queue and use it that way.
Any other questions? All right, thanks everybody.